2 sets of parallel lines.
2 sets of parallel sides. Good. Anything else?
Um, they can have 90-degree angles.
So for a parallelogram, that's not a requirement. There's something about the length of the sides
Oh,
that's important.
they're all the same length.
Don't have the same. Like for parallelogram, there's just opposite sides are congruent.
Opposite sides are congruent.
What I'm looking for here, this will really help. Let me just get a moment here to find it. So I have a really solid reference sheet here for quadrilaterals. Let me see if this is the right one. I don't like that one as much as this other one. Okay, so let me drop this in the chat for you. You can take a look at that. Also, snip it in here. I really like this chart. So let me start with this. We'll come back to this problem shortly, but this is
right.
really going to help you. So the chart shows you what a quadrilateral is. It's got 4 sides, but everything has 4 sides. Okay, so everything over here to the left has 2 sets of parallel sides, and trapezoids have 1 set of parallel sides. You probably haven't gotten to kites yet, but they have 0 parallel sides.
We have been messing around with kites.
Okay. Okay, so the way they're first initially organized is by the number of sets of parallel sides. Okay, now if you look at page 2 of this document, it gives you the more detailed information that you need for like what is a parallelogram. So let me snip that in, and this is the stuff you're going to be tested on. So you already kind of told me some of this. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. You need to show something here to make it a parallelogram. Okay. Now the first one's enough. Okay. So we're going to do that here. So we need to prove, and I guess I would like to have seen you label these vertices. I know that I don't do that very, very well, but you definitely want to label them.
Yeah, the pictures I sent you isn't the like finished work essentially.
Okay. Okay.
Which I have, thankfully. Yeah, I have a. I mean, if you want me to, I can send you a picture with it, like with all the right stuff filled out.
No, it's not necessary. Just that it's important here just to for me. So we need to find the slope, and I'll just arbitrarily choose. We need to find the slope from A to M.
From
Okay.
A to M.
A to M. I'm just choosing that side. Now, for me, when I've got a picture, I just count. I just count rise over run. Like A is going down 3 and right 1. You see that?
Yeah.
And what I'm really hoping is that the slope from T to H is exactly the same.
Oh, right. Yeah, then that would prove that they are.
Well, it proves that those are the parallel.
Yeah.
So what is the slope from T to H?
It would also be minus 3 over 1.
Exactly. Yeah. So that proves you have 1 set of parallel sides. So now you got to find the slope from A to T.
Then that would be you're moving up 1 and then to the right by 4.
3.
How did? Oh, yep, 3. I don't know how I miscounted that.
And then you need the slope from M to H.
And then M to H up 1, 1, 2, 3. Also 1 over 3.
Okay, so we know that there's 2 sets of parallel sides. So we've confirmed that this is a parallelogram. Okay, that's the first step. Now, I just want to make a comment on slope here. Slope is left to right. You cannot go right to left. Like don't try to go from T to A. You'll be very, very confused. And I did this very carefully on the right. Okay. Now let's go look at what a rhombus has. Okay, so let me go snip this in. So all properties of the parallelogram. So we've already proven that it's a parallelogram. But have we shown that all sides are congruent?
No, we have not.
Yeah. So to do that, we have to find the distance, and I'll grab this picture again. We have to find the distance between each of the vertices. Now that's where that triangle thing is going to come in that you were talking about. So we've got M, A, T, H. So we want to find the distance from M to A, and you were right here. There's a triangle. There's this triangle in blue here. Maybe that's not a good color. I don't know. How's that color coming in on your side?
Oh, it's good.
Looks good. Okay. So the key is that it's got a height of 1, base of 1, and you can say, oh, it's 3 squared plus 1 squared square rooted, or the square root of 10. And then you have to do that for all 4 sides. So we'll do from A to T. We'll find the distance from A to T.
So you're just putting in the slope, or I mean the rise over run.
It is that, yeah. Isn't that interesting?
Square roots, and
yes.
Then get what it equals.
Yes. So it's 1 and 3 square rooted. It's not enough to just do 2 of them. You have to do all 4. So it's very time consuming to do it. So from T to H.
That would be 1 squared plus 3 squared, which also would equal square root of, wait a second. Yes.
Square root of 10.
Because, okay, yeah, my bad. I was looking at that and I was like, wait a second, that would equal, I was looking at the 2 and the 1 wrong.
Okay, and the last one here, again, you make that triangle. Because it's a parallelogram, you could do a couple other things. Like you could say, since it's a parallelogram, AT is the same as MH. It's not that, it doesn't take that long to calculate it.
Yeah, okay, wait. One question. Does it matter the order you go in for the right angles? Like, should I go from...
No, the order does not matter.
Okay, so like if I wrote H to T first, it just wouldn't matter.
That's fine.
It's just addition.
Okay, so that's unfortunately not enough, because a rhombus, a square has all sides congruent. So you got to do something else. And the big one with the square, the differentiator with the square, is that the slopes meet at 90-degree angles, or the slopes are perpendicular. Okay, so the key here is that you need to take, and I guess I need to grab this picture again. I don't know how they do this in the classroom. It's like it gets pretty messy.
Yeah.
Trying to do all this. So what you have to do is prove that, like, and we'll just pick, so let's go MATH. You want to show that the slope from M to A is perpendicular to the slope from like A to T. And we actually already did that. We found from at A to M, sorry, A to M is -1. Sorry, it's -3/1. And the slope from A to T was 1/3. So when you multiply those together,
that equals -1.
Yeah.
And then,
so that's enough. That's enough to show that they're perpendicular. You really should show, though, that like the other one is 90-degree angle, but see, the thing is, once you prove that that's 90 degrees, and that's why you got to almost ask your instructor what they want here. Consecutive angles add up to 90 degrees, so that means this one's 90 degrees. Opposite angles are congruent, so that's 90 degrees, and that's 90 degrees. So once you prove one, you've got them all. But it's more of a proof than anything else.
Okay. So for the -3 and the 1/3, that's just the slope, correct?
Yes. Yes.
Okay. And then
you have to show that their product is -1.
So Why -1? Is that just because
That
it's
perpendicular slopes multiply to -1,
okay?
always.
So it's always -1, right? Yeah, because it's got to be the same. Okay, so -3 and 1, and then 1 and 3. Okay, yeah, now I get that. All right. And then with that, how do you know? Like, does it matter which two like letter number sets you use?
No, see, okay. Like I think the way this problem is written, I think you're supposed to assume it's a rhombus, so you have to then go from a rhombus to a square.
Uh-huh.
And the key there is that the angles are 90 degrees.
Mm-hmm.
Okay. So if you get one of them as 90 degrees, okay, like that's what I was trying to get you to like buy into. If one of them is 90 degrees, okay, then opposite angles are congruent. So you got another one that's 90 degrees. That comes from being
Yeah.
a parallelogram. In a parallelogram, if you look at number 6, let me scroll up to number 6. And I know you're not going to remember all
Yeah.
these, but consecutive angles are supplementary. Okay. So that
Mm-hmm.
means that this one right here and then this one down here are supplementary. That means that's 90.
Mm-hmm. And
And then you could
since
say opposite
same
angles are
logic,
congruent
yeah. But
or
like
consecutive angles. But one gets you all of them because you already know it's a parallelogram.
one gets me all of them because I already know it's a parallelogram.
Because you start mapping them like, oh, that gets you that and that gets you that.
Uh-huh.
You don't have to find all the slopes.
So
Now or all the go ahead.
would that
Sorry.
be like a parallelogram like diagonal conjecture
You
inside of
well, if it's a parallelogram, and in this case, if it's a rhombus,
mm-hmm.
if it's a rhombus, you already know a bunch of things about it.
So
You just have to figure out the one thing that differentiates it with a square.
okay.
And the one
All
thing
right.
that and that's what you're going to be tested on, I
Okay,
think.
so all right. So would it make sense? So like I have these like definitions for things that are kind of relating to that. So for this problem in specific, would I call it like a square diagonals conjecture since it's a square, or would I use a rhombus since it was originally a rhombus?
If you're looking for like the statement that goes in a proof, um, you want to use the converse of the definition of a square,
Mm-hmm.
because let me snip that in here. The square, well, this one's not great. Um, so it's like if it's a square, you know all these things. Like you know that it meets at 90-degree angles.
Mm-hmm.
Okay. When you're trying to prove that it's a square, use the converse. You always use the converse when you're going backwards, meaning you're using like some feature to prove that it is.
All right. Converse, backwards, square. All right.
It's let me give you a simpler example.
Yeah, that would be appreciated.
This is an equilateral triangle.
Mm-hmm.
What does that mean if it's an equilateral triangle?
All the sides are the same. Or
Okay,
I
so that means
mean, all the
all
like lengths.
all sides are congruent.
Yeah.
What about the angles?
Um, they all equal up to 180, and they're all
All angles are congruent.
yeah.
So if it's an equilateral triangle, then you get all this stuff on the right.
It's an equilateral triangle, then you get all that stuff on the right. Okay.
Okay. But now if you want to go backwards, if you want to like, let's say you get a problem on a test and you figure out that all the sides are the same
Mm-hmm.
because you use the distance formula, triangle ACE.
Then I would
you would have to use the converse to go backwards, because it's like you have the output, but you're going backwards to get the input.
Okay. All right.
Have you
Yeah.
ever have you ever played the game where they're like, what has, I gotta be careful here. Okay, they'll just there used to be this game that people would play where they would say, what do you call a person with like one leg longer than another? Okay. And it's Eileen. Eileen. It's a joke, right?
Oh,
Okay.
all right.
Okay. So it's like, but if I said, here's a picture of Eileen, tell me what you notice about it. And you're like, oh, one of her legs is longer than another. Okay. We're just going backwards
Mhm.
in these problems.
Okay. All right. Yeah. So you're just basically saying what you already did.
Yes.
Okay.
Like another example here, if you watch sports, um, I'm assuming you watch sports, and if you walk away from the TV and you hear like a noise, you sometimes know what happened, even though you know what it came from, even though you didn't watch it.
Yeah. Yeah.
Okay, and that's kind of what's going on here.
Okay. All right. Yeah. All right. That makes sense now. Like why that's all there, and like what it does essentially.
All right. So let's see here. You sorry, you lost this stuff. There it is. Can we do 5 or did
Yeah. Let's do it.
okay. Okay, in kite, W, X, Y, Z, prove the diagonals are perpendicular. So this, again, this is kind of written odd. Like, are you supposed to assume it's a kite? And
Yeah, I think it's like with this, it's like do it, and if it's not a kite, then you're wrong.
okay, okay. Because what I recall of your test in this part of the course is they give you 4 points and they ask you like what it is,
Yeah.
and
Yeah,
you have
I actually have my tests if you'd want to see that.
let's
Just
do this problem, and then you can send it over. But the
all
reason I'm
right.
asking is because if this truly is a kite, like if it's given that it's a kite, it's kind of like that example um, I just gave you, where
Mhm.
then you already know the diagonals are perpendicular. Okay,
Yeah.
so
Yeah, you
but
already like
but
know some stuff just from
like
that.
like that it has to be true. So, but what I think they're trying to get you to do here is they're trying to show that this line that I've just drawn, which is W to Y, you have to prove that WY is perpendicular to the other one, to ZXZ. You have to prove that they're perpendicular
Hmm.
because those are the diagonals. Okay, so we need the slope WY. Now you got to be careful here. It is rise over run. How much does it rise? How much does it go up
It goes up
from W to
from
Y?
W to Y. It goes up 4.
Nope, W to Y. It
Oh,
runs
sorry, my
4.
bad. Yeah,
It runs 4.
yeah, it just goes over 4.
Yeah. So we can make a reference here to Halloween. Let's say you have no candy and 4 kids at the door. How much candy is each kid getting?
No candy.
They're getting 0. Okay. Division is a sharing problem. It's a sharing problem. If you don't have anything to share, people get nothing. Okay.
Mhm.
Now the challenge here is like, well, what is its reciprocal? Well, you can always write a number over 1.
Always write a number over 1.
Yes.
Okay.
So the perpendicular here to this is the perpendicular for this would have to have a slope that's a reciprocal of this, like 1 over 0. Okay.
Mhm.
And the problem is like, well, what does that even mean? So the slope from X to Z the rise is minus 6 over the run of 0.
Minus 6 over the run of 0. So then that's the same thing as the one before, even though it's a 6, right? Or a
Yeah,
negative.
exactly. So these actually are perpendicular. I don't really like this though. I think I'd rather you say something like it's x equals 0 and I'm sorry, it's y equals 0 and x equals 2. And we know that somehow you'd want to say that horizontal and perpendicular, I'm sorry, horizontal and vertical lines are perpendicular.
All right. Yeah, yeah.
So where I was going with asking you, telling you about the test is there's kind of like there's and I'll just use this as an example before you send anything over. You generally do the following. You generally find the slope between all the points and you find the distance between all the points to start. And that helps you to narrow down your choices about what it could possibly be.
Yeah.
Okay, so if you want, you could send over some questions, or we can keep looking at some of these problems here.
Okay, I do have one thing about the problems, like when I do it, or actually, I have all my work for that problem for problem 5. Wait. Sorry, that's actually a different problem 5. On the other one where it's geometry coordinate proofs for a trapezoid, I have like kind of a good example of like what's expected with this. Would you want me to send that over?
Yeah, that'd be fine if you want us to look at it.
And yeah, thanks for the help with that other test, because or with our last meeting, because my teacher wasn't being clear about when the date would be. And unfortunately, the quiz was the next day, so it's a good thing that we had
Oh,
that.
good. That's good.
Yeah, I got an A on it, thankfully, so that was good. Thank you.
Well done.
Because I definitely would not have been able to get that good of a score without you.
Yeah. Well, you're really moving into the harder part of the course here, so just keep it up, and we'll see.
Yeah, yeah. I kind of like this stuff. Funny enough.
Oh, good.
All right. Yeah. All right. Just sent it. Yeah. I don't know. This is kind of like good geometry, in my opinion. It's got like a good mix of like algebra and new stuff where it's not like too tricky.
Just waiting for it to show up here.
Yeah. And here, I'll
There
go
it
look.
is. I got it. There it is.
All right. Awesome. And it's the upper half where there's like
Upper half. Okay,
yeah.
so we got the 4 points there: 0, -1, 2, 1, 4, 2, 6, 1.
Mm-hmm.
Okay, let me graph that in another window and then snip that in because we're gonna need the figure. Now, did they tell you it's a trapezoid, or you're supposed to prove that it's a trapezoid, or you're just not sure what it's supposed to be?
Basically, it just said all those numbers and then trapezoid on the side of it.
Okay, so let's just say we didn't know what it is.
Mhm.
And it is a good idea to graph it to
Yeah, I always
to
just graph
just
it
to
visually.
just like say like, well, I think it's this, and then it's like if you know your target, it's a little easier to hit it. What's the second point? R
Um,
is that 1 1?
yeah, sorry, 1 1. Yeah, when I was doing it every time, I was like, oh, I should make both of the ones have the like little lines on it.
2, and the last one is 6 1.
Yeah.
Okay, perfect. All right. So let me snip this in. Actually, I need to use the letters T, R, A, and P. Trap. Oh, that's creative. All right. All right. Yeah, there's a lot of 4-letter words you can't use.
Yeah. Oh yeah, I guess that's true. I guess you can get really creative with that.
Yeah. Okay. Yeah, so if you start connecting the lines, you're like, ah, that looks like a kind of looks like a trapezoid. Okay, kind of looks like a trapezoid. So the thing with a trapezoid is that it's got one set of parallel sides. Okay. Now before we even say that, like you already know this is a quadrilateral because it's got four sides. Okay, so it's something in that it's something in this picture here
Mm-hmm.
because it's got four sides. Like maybe it's just a quadrilateral, but it could be anything underneath. Okay. Now, so what I would do is find, that's what I mentioned before, I would find the slope between everything and the distance between everything.
So you do that before.
I would just do that right away. Like I wouldn't, because chances are you're going to use it. And you do need that here. Like you need to prove that the slope of RA equals the slope of TP.
Uh,
And notice I went left to right, R to A, T to P, left to right.
yeah, just like the slope would on when you're
Yeah.
doing it visually.
So can you tell me the slope from R to A and T to P?
Um, sorry, what? M to R?
R to A,
Oh, sorry, my bad.
R to A, yeah.
That would
That's right.
be
This is
one and
one, by the
one,
way.
and then you'd be moving over three to the right, and then one up. So one over three.
Yes, it's rise over run. It's different than X and Y, so just keep that in mind. How about from
Mhm.
T to P?
And then T is -1, and you're gonna move up one. You're gonna move up two,
Okay, so
and
rise of
then
two, run of.
6.
Okay, so are those the same?
Yes.
Okay, yes. So this is enough, but this just says that there's one set of parallel sides. You also need to prove that the slope from T to R does not equal the slope from A to P. So notice how I mentioned you need to find the slope between everything.
Uh,
You don't get out of like calculating the slope. So it's a good practice to find the slope and the distance between everything in these
yeah.
problems. Okay. All right. So what is the slope from T to R? T to R.
T to R. The slope to T to R would be 2 and 1.
2/1. How about from A to P?
That would be 2 and -1.
What's the rise and what's the run? What number goes in the top? What
Oh,
number goes in the bottom?
1 over -2.
So if it's okay, so the
I
run
mean,
is
sorry. 2 over negative. Sorry, I am. All right, yeah.
yeah, no,
Here.
you got the late spot. I mean, I'm tired too.
Yeah.
The slope is rise over run. And the rise is the top number can be positive or negative, but the bottom number is always positive. That's
Mm,
because you're always going to the right. And so don't make the classic mistake of going from like P to A.
mm.
You got to go left to right. We read left to right. I don't know what else we do left to right. We do left to right.
Yeah, yeah.
That's what we do. Right, left to right, read left to right. Okay. It's interesting.
Um,
You make the case though in math, you do stuff right to left, especially like multiplication.
oh, yeah, that's true.
So here's what we've proven. We've proven that it has one set of parallel sides. That is sufficient. That is sufficient because the definition of a trapezoid is that it's a parallelogram with just one set of parallel sides.
Uh-huh.
That is sufficient.
And
So
that would
you,
be from T to R and then A to P.
it means RA is parallel to TP.
Hmm.
That's what we've proven.
Oh, okay.
Now, if you go back to the picture that I sent you, and I'll scroll up to it, there are a couple of different types of trapezoids, right? There's an isosceles trapezoid and a
Yeah.
right trapezoid. So maybe this is like a more special trapezoid.
More special trapezoid.
If you're like, what do you mean by that? Well, maybe the distance from T to R is congruent to the distance from A to P. That would make it an isosceles trapezoid.
I guess Yeah,
So,
that's
so let's draw the triangle. Okay. And you said it before, that was really, it's a good thing. It's the slope. It's 2 and 1.
uh-huh.
So the distance from T to R is 2 squared plus 1 squared.
And that's 5.
Square root of 5. Then we're gonna do the same thing for the next one from A to P. Okay, which is 2 and 1. Square root of 2 squared plus 1 squared.
That's also square root of 5.
Square root of 5. So notice they're the same. These are congruent. So it is an isosceles trapezoid. Now I didn't ask for that, but you should be able to say, oh, maybe I can go a bit further if it asks for it on the test.
Yeah, yeah. Okay, so having these triangles, like I wouldn't make it go from P to T, or would I? Because do I need to figure out the length from
No. For a trapezoid, you only care that they're parallel. They're never going to be the same length. Okay.
Okay. So for a square, I'd also do this for a square probably.
For square, you need to find the distance of all 4 sides. You
So
generally need to find the distance of
only doing
everything.
it for the parallel sides.
What's that?
You're just figuring out like the length just for parallel sides.
Well, for a parallelogram, I would.
Mm-hmm.
Like I think you're going to get a question where they give you 4 points and you have to prove that it's a parallelogram. So you have to prove that 2 sets of parallel sides and then that opposite sides are congruent. So you got to find the distance and then the slope between all of them.
Mm-hmm. Okay. All right. Um, so then let me think. If there's
So this is it. Like once you get there's one set of parallel sides, boom, you've got the trapezoid. It's just I noticed, and maybe you would too, that you can actually go a bit further and figure out if it's a certain type of trapezoid.
yeah. Sorry, one more question that's like just a little bit like I mean it's related to this, but it's not related to this problem. So with those triangles, for a rhombus, would you do it for all 4 sides on a rhombus as well? Because they're
Yeah.
all
Yeah, because you have to prove that all 4 sides are congruent.
okay.
I like to think of a rhombus as a pushed over square. So you like
Oh.
imagine putting a force right there, pushing, and it pushes it all over.
All right. So then,
So all 4
okay,
sides
I
are,
guess that one's pretty obvious. Do you know like if a square's angled a certain way, like do you know the way to tell the difference from that and a rhombus? Is it just like the 90-degree angles?
you have to figure out if the slopes are perpendicular. So what the teacher could do, and this is why it's so important to find all the slopes and all the distances, is that they could give you something that almost looks like it's you know a rhombus,
Yeah.
but it's just not.
It's just like could be any of those.
It's like one off in one direction or something. And
Uh-huh.
I'm pretty sure what I just made is a quadrilateral
Mhm.
because it's not parallel. It's not even parallel. And like even though it kind of looks like it, I think if you count here, it's like one off. I don't know,
Yeah,
maybe.
yeah.
But the point is you use this information to figure that out.
All right. And then so like is a quadrilateral, is that like a kite?
Nope, it's just 4 sides. Okay, we need to
Okay.
go through this picture again.
Sorry.
This is really important. Okay, let me grab it.
I'm gonna
Okay,
make a little flashcard based off that.
and I dropped it into the chat. I think you get the files at the end as well. So any four sided thing is a quadrilateral.
Uh-huh.
Any four sided shape is a quadrilateral. Okay, but and see how they intentionally made this like ugly
Yeah.
up here. Okay, like you like squares, and I like squares too. They're great. Rectangles are great, but most four sided things are not that special. Like
Uh-huh.
the more specific they are, the more special. Okay. So most things, if they're four-sided, they're quadrilateral. And I think we talked about this a long time ago in the course. Every, let's do it this way. every square is a rectangle, but not every rectangle is a square.
Uh-huh.
Every parallelogram is a quadrilateral, but not every quadrilateral is a parallelogram,
Mm-hmm.
because it could be a kite or trapezoid. But kite, every kite is a quadrilateral,
Mm-hmm.
but not every quadrilateral is a kite, because it could be a trapezoid or a parallelogram.
And then any four-sided shape is a quadrilateral.
Every four-sided shape is a quadrilateral, but not every four-sided shape is a parallelogram.
Mm-hmm.
So
Okay.
you gotta be really careful. Like this is the hierarchy. Like they inherit properties. Like, yeah, parallelogram has four sides. So does a kite. So does a trapezoid. A rhombus has four sides, but it has congruences.
Okay. All right. Yeah, that makes a lot more sense this time than last time. Just kind of funny. It's not. Okay, wait. So how does every rectangle, or not every rectangle, how can some rectangles be a square or the other way around? Because, like, I understand everything else except that one for some reason.
Give me just a moment, please. I need to deal with something.
Of course.
All right, go ahead and ask me your question again.
Oh, so you said something with the squares and rectangles. Like, I get everything else, but, like, how is some squares a rectangle, or how are, like, some rectangles a square?
Well, so it's the way this is, let me write it out. It's every square is a rectangle.
Uh-huh.
Okay, and let's just start with that. The reason every square is a rectangle is because of the following. Okay, let me go grab the let me go. Here are the properties of a rectangle. Okay, so let's look at a square here. Or I'm sorry, let's look at a square. Just draw this correctly. We'll go through this list. Okay. Does a square meet at right angles?
Yes.
That's the second one there. We already know the first one's true. The diagonals congruent?
Yes.
Okay. So we know that a square has that, and the rectangle has this requirement. So we know that it's that way. The main difference here is that in a square, okay, the opposite sides are congruent, but they're not all congruent.
Mm-hmm.
So the major issue here, that's why you add this, but not every rectangle is a square.
Because it doesn't meet
Be-
all the
be-
criteria.
yeah, it's got to meet every single one. You're usually missing like one little thing, and that's why
Okay, and that's why it's not a square.
that's right.
Okay. All right, yeah, I don't know why like it's like the exact same concept as the rest, but I don't know why I didn't get that one.
It's hard because it's like what do you mean by that? And I get it, and maybe it's still not clear. But the point is that you're getting more specific as you go down this list. You see this, probably saw this in chemistry, is you're getting more specific.
More specific.
And that means there's like more requirements to do this.
Okay. All right, yeah. That makes sense. More reasons, more explanation. All right. So I guess I have a question for when I'm writing out like the y squared minus y1 over x squared minus x1. That's slope, right?
Yes, but our preference, and this is really important to save time on a test,
Oh.
is to just count.
Yeah.
You can do the ordered pairs, but yeah, it is y2 minus y1, y subscript 2 minus y subscript 1 over x2, x1. But I would just count, especially if you're going to go to the trouble of drawing it.
Yeah.
But then you got to make your drawing good, and if you don't have graph paper, that's
Hard.
hard. Yeah.
So, okay, so I have a question. So, my teacher didn't really teach us how, like, she taught us where it's like have your statement and then reasons and like
Yes. Yeah.
write the like y squared minus y1 x2 as your like reasons. How would
Okay.
I?
Well, then you'd have to, yeah, you have to do that then. You have to do, you have to say the slope is 1/2, and you have to give, you know, something that works out to that 2 minus 1 over 3 minus 1.
Uh-huh.
You have to, you'd have to show that.
Okay, so it's like there's not really a wraparound for it. Like I just kind of have to do it.
I guess. I mean, yeah, I mean, I guess you can't just say, look at the graph. If the instructor wants this,
Mhm.
you have to give them that.
All right. Man, that's kind of annoying knowing that there's like technically a faster way to do it.
That's the whole point of this course, is to prove things that we take as being correct.
That's true. Huh. Okay. Well, I'm glad I asked that so I didn't like mess that
Yeah.
up anymore.
All right.
So it looks like my teacher almost wants me to do like both, if that makes any sense.
It very well could be. You gotta give them what they want.
Hmm.
Let me so there's one other, I've got this other quadrilaterals. I don't like it as much, but let me just briefly go over this one with you. It's good in another way. Like let me snip in like a kite, for example.
Yeah.
It's a good reference for like the fact that it shows you the figure with some of the stuff in there. Like the diagonals are perpendicular. The angles are bisected.
Uh-huh.
Okay. Let me get to the rhombus one, because I think that's sometimes easier to see here. So like here's what my perception is that you have a test where you are expected to know all these properties, which is pretty overwhelming. But in a rhombus, all the sides are congruent.
Hmm.
Okay. The diagonals bisect the angles. That means that angle is congruent to that angle, and that angle is congruent to that angle. And the diagonals are perpendicular. Oh, perpendicular bisectors, yeah. So that's congruent to that. That's congruent to that. Stuff like that. So like what I guess was trying to show you is like this other one might be good to like go through the list and like mark up the
Mark out the stuff that it's
yeah,
saying.
just to kind of visualize it so you know what you're looking for.
All
And
right.
it used to be that they would give you this chart, and they don't do it anymore, but it had like all the like properties on the left and all the shapes on the top, and you had to like figure out, which ones had it. But I think I would stick with this picture. You really want to know. You really want to like get this, like mentally get some visualization of this, because it'll really help you
Uh-huh.
on that.
Get that mental screenshot.
Yeah. And then if you can, like any of the ones that are hard for you to remember, just look for the differentiators between them.
Okay. All right. All right, yeah, thank you.
All right. I think that's it for tonight, Zach. I appreciate you scheduling. Definitely probably take a look at the video when you got time, and hope to see you again before your next test.
Yeah, all right. Thank
All
you,
right.
Matthew.
You're welcome. Bye now.
Yeah.